1. All right, so we saw the Bay of Fundy tides. The tide rolls in, the tide rolls out, the tide rolls in, the tide rolls out. Highest tide differential in the world. Here's where the Bay of Fundy is. It's right there. There should be an arrow pointing to it. So yeah, now there is. Yeah, that's the Bay of Fundy. 100 billion gallons of water twice a day rolls in and rolls out. So that's a lot of water, right? A lot of H2O, right? Let's see. The Bay of Fundy in Nova Scotia is known for having the highest tidal range in the world. Approximately every 6 hours and 14 minutes, the high tide and low tide switch. Okay, every 6 hours. This is true. I looked this up. Every 6 hours and 14 minutes, we go from a high tide where you saw it fill up underneath those rocks to the low tide where the people were walking on the ocean floor. Crazy people. Okay. Well, with the difference of, this is incredible, 55.8 feet. Not quite 59, 56. Sorry. These glasses are messing me up. Sisu, baby. All right. So every 6 hours, 56 feet of water comes in and comes out. We saw in there it's 100 billion gallons, which is, if you measure it in bathtubs, it's a lot of bathtubs, right? If you measure it in bananas for scale, that doesn't really work, right? That's a lot of yeah. Speaking of bananas, there was a squished banana when I walked in this morning at the bottom of the stairwell, and it was just like, it was sad banana. It's like, oh man, it's gross. If we assume that on a particular day, that we observe the low tide at 8:45 a.m., low tide at 8:45 a.m. So we're out walking on the seafloor at 8:45 a.m. when the tide is at its lowest. Okay. Go ahead and sketch the graph of the tides in feet. Okay, and that's going to be above sea level for the entire 24-hour day. And look what we're measuring our x-axis in minutes after midnight. Minutes after midnight. So we're going to use minutes on the x-axis. Okay. Assume the sinusoidal axis is at 0. So we're going to let y equals 0 be essentially equilibrium, sea level, and then the tides will go to a high point above that, and then they'll recede to a low point below that. Okay, so that's what we're going to do first. We're going to sketch the graph. Now, to sketch the graph, we first need to get our A, B, C, D, and P all in order. Bless you. Okay, so what would the amplitude be? If the tide differential is 55.8 feet, that's the difference between the high and the low. Does that mean the amplitude is 55.8? Very good. If you think about, the sinusoidal axis is here. If you know the high point and the low point, the sinusoidal axis is in between. So the amplitude is really half the distance between high and low. So half of 55.8 is your amplitude, which is what? 27.9. Yeah, 27.9. 27.9 feet. Okay. Once we have A, we can find D. And in D in this case is what? Are we shifting it up or down based on what it said? Assume that the sinusoidal axis is at y equals 0. So we don't want to shift it up or shift it down. So we'll let D equal 0. Okay. And that'll be essentially sea level. If there's an earthquake, then all the coffins buried there become marimbas temporarily. Okay. Not marimbas. Is marimbas? Is those the castanets? Maracas. That's what I'm looking for. I can't even get, I can't even get the joke right. If there's an earthquake, then all the coffins buried in there become maracas temporarily. I don't know if you need a clap for that. Maracas, yeah, maracas. Thank you. All right, now the P, and I'm sure there is P in the Bay of Fundy, right? People walk in and they're like, "Who's going to know this fish?" Right? But our P is period. So what is the period? Every 6 hours and 14 minutes, it goes from a high tide to a low tide. What fraction of a period is that? Half. Good. So let's come down here and say 6 hours. And I have a horrible short-term memory with these glasses on and without the glasses on. 14 minutes. Okay. So this is equal to 1/2 the period. Now we can do one of two things because we want to measure the x-axis in minutes. We can either find the period in hours and minutes and then convert that to minutes, or we can convert this to minutes and then double it. What do you want to do? Let's convert it all to minutes first. So 6 hours is how many minutes? 60 hours times 6, right? 60 times 6 is 360 minutes, right? Plus 14 minutes. That's a half the period. So 374 minutes is half the period. And therefore, the period is twice that, which is 748. There's the period. Every 748 minutes, it returns back to where it was. You stand on the ocean floor, you hold your breath for 748 minutes as the tide rolls in and comes back. You're back on the ocean floor. Challenge is now set to you, David Blaine. David Blaine, hold your breath for 748 minutes. Stand on the ocean floor, Nova Scotia. Let the tide roll in, the tide roll out, and you're still there. Wow. Or maybe that's a Chris Angel challenge, right? Mind freak? I don't know. Okay, so that's awesome. Are we ready to go ahead and start putting down some tracks? Well, let's do one more thing. The C always depends on what we're going to call the equation. So the B value, let's go ahead and find the B value. We need it for the equation, not for the graph, but we'll have it ready to go. So remember, B is 2 pi over the period. Well, that's easy, right? That's 2 pi over 748. And of course, if you let the 2's divide out, you're back to 374. So pi 374 is your B value. We'll need that for the equation soon enough. Pi over 374. Okay. Now, what's that? Oh, the R. We didn't do R. A, B, C, D, P. Oh, we need R. There we go. Thank you. R is the range. Now, this one's going to be kind of easy, right? Because the sinusoidal axis is 0, we go down 27.9 to a low point, and we go up 27.9 to the high point. Thank you. Okay, I think now we are ready to lay down some tracks. Let's go ahead and create a graph here. There's my y-axis, maybe scoot a little bit further to the left. And now we can draw the x-axis right in the middle, okay? Because that's going to be equilibrium, that's sea level. And let's go ahead and get the y-axis kind of set up. It's the easier of the two. We'll use the space that we have. I'll use, let's see, I'll use blue for water, right? Unless there's a lot of P in it, then what's blue plus yellow? I don't know. Green. Green? Yeah, maybe I should use green. I don't know. I don't know about those Canadians, you know. 27.9. They are nice. Oh, sorry for peeing in your ocean. That's not how Canadians talk. Yeah. Yeah, that's Minnesota. Minnesota. Yeah. Here in Minnesota, the state bird is the mosquito. You're darn tootin'. Right. 27.9, negative 27.9, right? So far, so good. Let's go ahead and label the axis. What do you want to call the height above sea level? Do you want to call it H for the wave, for the actual wave height or the tide height? Or do you want to call it F for Fundy? Yeah, okay, cool. Let's call it big F. Big F for Fundy, big F for Friday. So we'll call this big F of T. It's the height above sea level, okay? Measured in feet. Height above sea level. All right, so we don't really need to draw our sinusoidal axis because it's the x-axis. That's cool. But the fun part, I should say, not the more difficult part, but the fun part is laying down the horizontal tracks, right? We have a reference to a point, right? It says, assume that we observe the low tide at 8:45 a.m. Well, we're measuring time after midnight, aren't we? Time after midnight. So let's come down here and we'll think about 8:45 a.m. First of all, I want to convert that to minutes after midnight. Minutes after midnight. So 8 hours after midnight is how many minutes? 8 hours is how many minutes? 8 times 60 is 480, right? Plus the 45 minutes, 525 minutes, okay? So at minute 525, after midnight, so at t equals 525, I observed a what tide? a low tide. So this needs to correspond to a low point on the graph. That's the only piece of information we have, okay? So now I'm going to come back and do a sacrificial axis. Remember, every high axis, low axis, high, the distance between critical values is a fourth of the period, right? I haven't really found that yet. I found the period is 748. I know half the period is 374. Let's go ahead and find a fourth of the period. So instead of bisect, let's just take half the period. What's half of 374? 187 minutes. 187 minutes. Okay, bless you. Bless you. So every 187 bless you minutes, it goes from low tide to equilibrium sea level to high tide, back down to equilibrium sea level, so on and so forth. All of our critical values are that far apart. Now, here's what I don't want to do. I don't want to just come out to my x-axis and say, oh, at 525, we're at a low point. I don't want to just do that because look at this distance I've created. I might have several more critical values between 0 and 525. And if I don't plan ahead of how to organize those, your graph is going to be horizontally compressed or stretched in certain places. So let's just kind of do a rough draft. I'm going to get rid of this y-axis. We know at 525 it's a low. Let's just go backwards from 525. Put yourself some critical values there. And now all I have to do is label them by subtracting a fourth of the period, which is what? 187. So let's do that. And I'll use the calculator for this. We're not in a number sense competition. So 525 minus 187, boom, that's 338, right? Let's do that again, minus 187, boom. That gives us 151. I forget how to say that in German. Okay. Now remember on your calculator, if you do something twice in a row, it remembers what you're doing. So you can either hit minus 187 again or hit enter and you get negative 36. Okay. So yeah, there were actually two more positive critical values between the y-axis and 585. Now here's the deal. Once you have a critical value that's negative and the next one being positive, you know where the y-axis is in between. Okay. So that's just getting the numbers. The scale is not necessarily correct. But now we can do this. Since 36 is smaller than 151, I'm going to go ahead and say that that distance right there, I'm going to call that 36. Okay. So now as I come out to the right and I put 151, I can't put 151 right here, can I? No, because now I'm saying that that distance there is the same as that distance, and it's not. It's actually 5 times that distance about, right? So you eyeball it, and as long as it's, substantially larger, I'll just say, how about right there? Okay. Actually, I need to make these distances a little smaller because I'm running out of room, right? So let me bring the 36 closer in. Let me put it about right there. How about that? And now I can bring this one over here. I want to make sure I have enough for at least 5 critical values, right? You need at least 5 critical values. So there's 2 of them. I'll go ahead and give myself another negative one here. Now I just try to eyeball and keep that distance roughly the same, right? So there you go. And then eyeball it somewhere in there, eyeball it, and then eyeball it. We'll do it like that, okay? So again, the distance between the y-axis and negative 36 and the distance between the next one. We got to make sure that they're roughly the same. Okay, now we'll just go through and label it. What was the one after the negative 36? It was 151. Then it was 338. And what was the one before that? 338 plus 187 is 525, right? Okay, and then plus 187, I've got it again. There's 712. And I got one more to label. Negative 36 minus 187, boom, is negative 223. Now, remember, we talked about negative values of t. Okay, let's label the y-axis now. We actually have time in minutes measured on the x-axis. Sometimes negative values of time don't really make sense. Like in the experiment of the guy starting the perpetual motion machine or when the Ferris wheel started. Negative time values don't really mean anything because you can go back in time when it wasn't going on. But do negative time values here have meaning? Absolutely. Maybe you weren't there to observe the tides the day before, but nonetheless, the tides wait for no man. They were doing their thing, right? So if we wanted to extrapolate back in time, we could determine where the tides were the day before, 2 weeks earlier, so on and so forth. Okay. All right. That is the important part right there. If you can get your x-axis laid out like that, you're in good shape. Okay. So we have essentially, set the table, right? We've set the table. We have our X and Y axis all labeled. Now we put food on the plates. Okay. So now let's go ahead and put our dots. You're going to be given, again, some piece of information that's going to help you determine where to put the dots. Well, bless you. It's a low tide at 8:45. So 8:45 again was at minute 5:25. So at 5:25, I'm going to put a low dot. Now, if you're given information about a low or a high, you only need one piece of information, right? Because there's only one way to go when you're at the top, which is down. And there's only one place to go when you're down, which is up. But if you were told that it was at equilibrium or at the sinusoidal axis, you would have to be told which direction it was going. So once we have this single value, now we can start placing the rest of them on there, right? If I go to the right, the next one's going to be on the x-axis at 712. At 338, it's back on the axis. At 151, it's high. At negative 36, it's on the axis. And at negative 223, it's at low. Okay. You need at least 5 dots. Do we have at least 5 dots? One of which is negative? 3, 4, 5. Yeah, we have 6. Okay. So now we just connect the dots with nice exaggerated curves. And make sure you emphasize the change in the curvature at the inflection points. And then wherever you stop, just turn the corner a little bit and keep going. Okay. There's a piece of the graph. And not only a sine, a wave function, but we're measuring on the y-axis wave heights, like actual wave heights, like Cowabunga Aloha. Hey, it's also Luau Day, Hawaiian Day. It's not like Nova Scotia Day, but we're in the water at least playing with waves, right? Aloha. Oh, I like how you wear it like a bandolero, yeah, right? Or a sash, right? Maybe not a bandolero. Okay. Once we have the graph, the equation is easily forthcoming. Yes, yes? Okay, so good. Let's go ahead and write ourselves the equation. Write that equation. So we're calling it big F for fun day, or fundy, sorry. It is a fun day. I'm already having a good time. All right, now the amplitude is 27.9. So I'm just gonna leave a little space in the front. Do you want to write an equation that is sine or cosine? Do you want it to be negative A or positive A? It doesn't matter. Sine or cosine? Sine. Okay, I heard sine. So I heard sine. So I'm going to put sine. And do you want the A value to be positive or negative, everybody? Positive or negative? Negative. Okay, I heard negative. So again, this is just arbitrary. So negative 27.9 sine. And now parentheses. What comes next in the alphabet? A, B. Did we find B? We did. Do not put 748 in there. That's the period. Okay. B is pi 3/74. Pi 3/74. Parentheses T, close, plus 0, right? We don't need to put plus 0. Now, notice that the y-axis, T equals 0, it's not a critical value, is it? So every single equation that I write is going to have a phase shift. If we want to do a negative sign, we need to be going where on this graph? We need to be on an axis going down. Do you see a spot where we're on the axis going down? I do too, right there, negative 338. So because it's positive 338 on the number line, it's going to be minus 338 here. So yeah, again, you could do this as a negative cosine if you want, which would be plus 223. You could do it as a positive sign by doing plus 36. You could do it as a positive cosine if you say minus 151. Of course, we did the negative sign, so it's minus 338. And of course, you could do another negative cosine by doing minus 525. You could do a positive sign by doing minus 712, etc., 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 and then plus 0. So there's our equation. Now, for the test, I'll have you write another one. Remember, you'll have to write at least 2 equations, one with sine, one with cosine, and at least one with a negative amplitude. So we could say, or f of t is, now we got to do cosine. So leave a little spot in front, negative 27.9 cosine. At least one of them has to be negative. They both could be negative if you want. You want to do negative cosine or positive cosine? Positive cosine. Okay. So I'm just going to scooch this over. I don't need a space for a negative in the front. So positive 27.9 cosine, parentheses, pi over 3/74, parentheses t plus or minus something, something plus 0. The d value is 0. Now for positive cosine, we need to get to a high point. High, high, high. Where are we on a high? What? 151, right? So t plus 151? Minus 151. Yeah, there you go. High. Axis, slow, axis, high. Axis, slow, axis, high. Axis, low, axis, high. Which one of those equations is correct? Both, right. Okay, cool. So now we can go to the graph. Go to y equals, make sure you're in radian mode. We're in radian mode. Check that first before you wreck yourself. Go to y equals. I'm just going to use the first one. Are you okay with that? Okay, good, good. Because if not, I was going to kind of argue with you a little bit. Like, why are you not for that? I mean, what's the big deal? I mean, for real, come on. Chill out, man. Negative 27.9 sine, parentheses. It opened it for me. So alpha y equals pi. Use the pi button. And then scroll to the bottom over 374. Click to the right. Open another parentheses. We use x minus 338. Close. Close. Right? Now, we don't hit graph. We go to the window, don't we? Go to your window. Go to the window. Window's right here. We want to graph it in this window to verify that the calculator is as smart as we. So x min, negative 223. Negative 223. X max, 712. 712. And then X scale, I'm just going to turn it off. Who cares? 0, 0. And then Y min, we need to put a little extra distance, right? So instead of negative 27.9, maybe negative 50. I don't know. So Y min, maybe negative 50. And then Y max, positive 50. So again, that gives you a little bit of space at the top and bottom. And then for your Y scale, I'll just turn that to 0. Turn your X scale, Y scale to 0 if you want. All right, now we'll hit graph, and we should see the portion of the graph that we've already drawn. If you don't see your graph, you got to troubleshoot yourself, right? Are you in degree mode? Did you forget a parentheses? Did you type a number in wrong? Have you adjusted your window to match, right? If you just hit zoom 6, you're going to be like, Mr. Corpy, I don't see the graph on the test. And I'm going to be like, well, here, borrow my glasses. Maybe these will help. Huh? Still don't see it. Well, I'm going to be like, well, what's your window, right? And you go to your window, and it's like negative 10 to 10, negative 10 to 10. And I'm like, think, right? You've already done it. So is this a confirmation that we're right? Yeah. Now that we know we're right, now we can answer the questions, okay? So we move on to the next part. That's part B. At midnight, the morning of, what was the water level in the Bay of Fundy, and was it rising or going out? At midnight. So this is part C. What time value corresponds to midnight? 0, because we're measuring the desk several times a day. So we're going to put f of 0 equals. F of 0 equals. Now, you could do it from the home screen. Hit trace, 0, enter. You don't have to do it, or you can do it from the graph screen, I meant to say, because 0 is in our window. It's a little bit faster, right? F of 0 is, write it down, 8.308. I'm a truncator. Feet going, make sure you describe motion, going what? Up or down? Going up. The tide is rising, right? So at midnight, right? You're standing out there in 8 feet of water, and maybe you're 9 feet tall, so your head is still above water, right? But it's about to cover you. Maybe you're 9 feet tall. Just maybe, right? Right. Midnight. So did we answer all the parts on part C? Yeah, it's gonna be okay. We got it. Was the tide coming in or going out? Oh, I said going up. That means the tide is going in. or out? Which one? If the water level's rising, is the tide going in or out? Yeah, the tide is coming in. So make sure we kind of answer the question. The water's going up, but I want you to know something about tides, right? Yeah. Don't eat Tide Pods. Don't. Okay. That's what you should know about tide. But it's coming in. Like yeah. That's funny. Yeah, okay. A, B, C, D is next. D, D, D. At 7:30 that evening, what was the water level? Was it coming in or going out? Okay. Now, crap. I got to do a little bit of work here. 7:30 that evening is 7:30 p.m. Yes. Holy cowabunga. Okay. So 7 p.m. is how many hours after midnight? If you're like military clock, you're like, I already know that, sir. It's 19:30, right? So let's do military time. It's 19:30, or 19:30, as we say sometimes when we try to be funny. So that's 19:30, but that's really like this, right? So 19 hours. We got to convert 19 hours to minutes. So I'm going to go back to my home screen. I'm not going to do this in my head. 19 hours times 60 is 1140, 1,140 minutes, plus the other 30. Boom. And we get T is 1170 minutes. So there you go. 7:30 p.m. that day is 11,000 or 1,170 minutes after midnight. Now I can say F of 1170. And if I try to do that on my graphing screen, guess what's going to happen? Error, right? Error. So I'm not going to change my window. I'm just going to do it from the home screen this time. So now I'm going to say alpha trace, access it from Y1, type in 1170, close parentheses, boom, there you go. It's negative 18.092 feet. Okay, so now to answer this question, since it's a negative number, let's see, what does it say? Was the tide water at this time, was the tide coming in or going out? Well, first of all, it's 18 feet below sea level. Would you agree? Okay, so is the tide coming in or going out? Well, let's see. You can hit second enter if you want, or just type it in again. Second enter recalls the previous line. And instead of doing it at 1170, let's do it at 1170 point what? 0.101 might work, but you might not see much of a difference. I'm gonna do a tenth. Okay, so a tenth of a minute later, and what's happening? Is it increasing or decreasing? Decreasing. The magnitude is increasing, but it's becoming more negative, so it's decreasing. So we would say the tide is doing what? Coming in or going out? Going out. Going out. Hey, we're going to be going out of here soon, right? Because we're on pep rally schedule today. Speaking of going out, 11:30 and 9:38. Okay, we got 6 minutes. Okay, so far so good. So good so far. Oh yeah, so good so far, right? A, B, C, D. Look, I knew the alphabet. At what times during the day was the water level 25 feet above normal? Okay, so for this one, 25 feet above normal. That means positive 25 or negative 25? Positive. So you got to be careful. If I would have said 25 feet below, you would know it's negative 25. Now, here's what I would do. Go to your window. We want to look for the whole day, right? So for the whole day, let's go from 0, which is midnight, to 24 hours later. That's 24 times 60. You could do 24 times 60 right there in your X max if you want. It turns it into 1440. So now I'm only going to be looking at the tides for that specific day. Yes? Okay. And now in Y2, I'm going to graph 25. And then I'm going to hit graph. So what we're looking for here is, where is the Fundy tide greater than or equal to 25? That's going to get you a check. Yeah. Now, this one is a little bit easier than one we did yesterday. We're not going to have time to do this, but this is the one where you store the values, right? Because these are both symmetrical, you can work with either one of those, find the 2 points of intersection, store them, subtract them, and then double it, right? So I'll just say that T sub 1 equals A and T sub 2 equals B, okay? And y'all can just say, oh, those are the first 2 points of intersection. So the time spent above is going to be B minus A, right minus left, big minus small. That gives you the duration. And because there's 2 complete ones, boom, there you go. Twice a day, the tides roll in and roll out. So whatever that number is, you just write it. You would type this in now, write it out, and put seconds on the end, okay? Or minutes, sorry. we're not going to have time for this. Does that make sense? We did that yesterday. So if you want to see how we did that for the other problem, go back and watch yesterday's video. All right. And then the last one here. If it is save, stupid, I'm going to fire my typist, right? If it is safe to moor a boat as long as the water level is what? Oh, crap. Does y'all have anything added at the end there? Okay. So why did it get cut off? Well, I guess as I was typing it, the water was rising, and I was like, okay, no more question. The water level rose. What this question is going to say is, if it's safe to moor your boat as long as the water level is within 10 feet of normal, what times during the day is it safe to moor your boat? So it would be, if it were 10 feet. So now you would say F of T is less than or equal to 10. And you would do the same thing that we just did on the previous one, except now you want to know where it's not above the intersections, but below. So it's just another way for me to do that. Okay. So anyway, that's it. Any questions? Bay of Fundy. It's a real thing. Real thing. You know what else is real? Friday. Happy Drive to Work Day, right? National Drive to Work Day. April Fools, it was National Walk to Work Day. I thought about celebrating that, but I didn't get up early enough. Yeah, I would probably be like halfway to work right now. I'd be like, where's Mr. Corpy, right? He'd worry about me. Was he at the Bay of Fundy and the tide rose? All right, so go ahead and clear your calculator. And Jonah Diaz is 12 to do. That's whoever wrote that. Good one. Good one. April Fools. Okay, nice. All right, y'all have a super duper rest of the day. Good luck, everybody competing tonight and in the future. And we'll see everyone at the pep rally.